Hello students. Is the soil mechanics so important in civil engineering course? Let me answer. It's as important as root of the plants which anchor the plant in place. The foundation of any building resembles the root of the plants which anchors the building on the ground surface. And that very foundation is laid on the soil. If you just take a look at the competitive exam questionnaire, you can find more weightage is awarded to soil mechanics subject. It is highly recommended not to skip soil mechanics in any competitive exam preparations. So here is a video that helps you to practice GATE previous year problems and solutions. And why specifically GATE questionnaire? All GATE questionnaire is prepared by the IITs, which are definitely framed to test students' aptitude skill in engineering. Hence, it is obvious that once you finish practicing GATE questionnaire, you will be in a position to solve any other competitive exam questionnaire. Each topic is split into two videos, that is part 1 and part 2. In part 1 video, you can find all 1 mark question and answer under a particular topic, and in part 2 you can find 2 mark question and answer for that particular topic. You can share and subscribe my channel for further updates. Let's get into the video. Geotechnical engineering can be categorized into soil mechanics and foundation engineering. For the subject geotechnical engineering, weightage given in the GATE examination is 15 marks, which overall tops the other subjects by weightage. Under soil mechanics, the topics need to be covered are these. Under foundation engineering, the topics need to be covered are these. Under the detailed GATE 2021 syllabus, under each topic can be noted down here. In this video, past 20 years GATE question and answer under the topic 3-phase system and relationships will be covered, and this is video part number 1, which has only the 1 mark question and answer. In part 2, we will cover 2 mark question and answer. So in this video, we will start with the 1 mark under 3-phase system. So under the topic, our recent question is a soil has dry unit weight of 15.5 kN per meter cube and specific gravity 2.65, degree of saturation 72%, considering the unit weight of water 10 kN per meter cube. So water content they have asked, we will have this following. They have given dry density gamma d and specific gravity 2.65 and saturation 72% and unit weight of water 10 kN per meter cube. This is what they given, and they have asked for water content small w. The solution for the given question, we need to have this important relation to solve this particular problem. So if you look into this relation, we have gamma d and specific gravity, gamma w unit weight of water. So this is void ratio is what we don't know. So we find this void ratio to substitute in this equation, because we have another relation this which has water content in it. So in order to find water content, we need void ratio to substitute in this particular equation. Just by substituting the given, we will have this equation. So from this we can easily find void ratio, as I said. So if we just calculate our void ratio, it is 0.7090. Let's take the second equation. So simply substitute the given and the answer void ratio in this equation. So if we just substitute, and we will arrive at the answer water content. So in order to represent in percentage, we will have this answer. Next question. A sample of 500 gram dry sand poured into a 2-liter capacity of cylinder which is partially filled with water displaces 188 cm cube of water. The density of water 1 gram per centimeter cube. The specific gravity of sand is, they are asking for specific gravity. So according to the question, there is a cylinder. They are pouring 500 grams of dry sand into it. So in that cylinder, it contains water in it. Due to pouring of this dry sand, some water is being spilled out. So that quantity of water, they have said it as 188 centimeter cube is being displaced from that cylinder. Okay, so this 500 grams, when it is poured in, exactly 188 centimeter cube is being spilled out. Okay, so the weight of the dry sand is 500 grams, and that particular sand 500 grams can occupy a volume of 188 centimeter cube, isn't it? Because that weight 500 grams of sand only spilled 188 centimeter cube water. So that means 188 centimeter cube volume is occupied by 500 grams of this dry sand. So I can take and write that my weight of dry sand is 500 grams, and that dry sand, this dry sand can occupy a volume of 188 centimeter cube, that is volume of dry sand. Okay. To solve this problem, we need two equations which gives specific gravity equation. So specific gravity G equals gamma S, unit weight of solids by unit weight of water. And this unit weight of solids, once again, it can be basically classified as weight of dry soil by weight of that dry volume, or weight of solids by weight of volume of solids. Okay. When I take and substitute in the gamma S equation, I will get my gamma S as 2.659. So if I just substitute once again in the specific gravity equation, gamma S by gamma W, I will get that 2.659 by 1. So which gives my specific gravity G as 2.6. My correct answer is B, 2.66. If the water content of a fully saturated soil mass is 100%, the void ratio of the sample is. In the question, they are talking about fully saturated and its water content to be 100%. If we just imagine that structure for the given problem, it is like this. It is only composed of solid and water, which is fully saturated. So we can write it as 100%. And water content, they have said it as 100%. In this question, they are talking about all these 3-4 terms in the question itself. So this relation will help us to answer the question. Let's just stop, take and write the given. Just by applying that 100% given data for saturation and water content, this is in terms of decimal system. So I can say my void ratio is the options. We can say that B is my correct answer. Next question. Natural condition. In natural condition, our soil has mass and volume, and after being oven dried, our soil mass is 1.8 kg, and that particular soil has specific gravity and water unit weight of water they have given, and asked for saturation, degree of saturation. So just take a look at the three-phase diagram. In this, basically soil has solid, water and air, because in the first beginning what they have said, at natural condition they have given certain datas. So natural condition means it will have air, water and solid. When it has all these three, what is your total volume that they have given and total weight they have given. So under natural condition they have given total volume and also total weight. In terms of mass they have stated. So we are not converting that mass into weight, just keeping it as it is. So talking about the another condition, dry condition, they have given certain data. So at dry condition, our three-phase system will change like this. The water is totally removed from the system. So at dry condition only solid and air is present. So at that moment they have given data. So at dry condition they have given dry weight in terms of mass, and then specific gravity of that soil and unit weight of water. So let's see what are all the important relation that is going to help us to solve this particular problem. So first they are asking for degree of saturation. So this popular equation of course is going to help us. So in this particular SE equals to WG equation, G is given, water content is what we are going to find it from the given data, and also void ratio we are going to find it from the given data, and after then finally we will substitute the found answer in this equation to find our degree of saturation. Uh, Basic equation for finding water content is weight of water by weight of dry solids. So this weight of water, I am going to write it, just replace this in terms of mass. So mass of water mw by md. So once again, uh, my mass of water, my mass of water can be replaced as like this. Total mass minus my dry mass will give you the mass of water, and then my denominator is as it is md. Just I'll substitute the given. So substituting my m and md in the basic equation of water content, I will get my water content value as 10%. Our next step is to find void ratio. So to find void ratio, first we will take and write an equation for gamma d. So another relationship also is there for gamma d. There we can find our void ratio. This equation we will have it to find void ratio. So for gamma d itself we have two relationships. We will substitute whatever is given in the both two equations so that we can equate it and then find our void ratio. So in this gamma d, if I substitute, I will get my gamma d answer in terms of kg per meter cube. Again, once again, in the second gamma d relationship, I will substitute this one 800 kg per meter cube here. But before that, I will convert that kg into meter cube in terms of kilonewton per meter cube, because unit weight of water they have given in terms of kilonewton per meter cube. So next step, if I substitute my gamma d in terms of kilonewton per meter cube in that equation, I will find my void ratio to be 0.5. So now it is easy to substitute everything in this equation. G I know, W water content I found it, void ratio I found it, so it is easy to find my degree of saturation. So just substituting the values, I have got my degree of saturation as 0.54, which is nothing but 54%. The ratio of saturated unit weight to dry unit weight of soil is 1.25. Specific gravity of solids 2.65. What is the void ratio? So just taking and writing the given gamma sat by gamma d ratio, they have given it as 1.25 and specific gravity capital G 2.65. The important relation or formula for this particular problem is these two relations, gamma sat and gamma d relationship. We will use it to solve this problem. According to the given, gamma sat equals to 1.25 times of gamma d. So just substituting for gamma sat and gamma d from the previously stated, we will arrive at this step. So let's just reduce that this equation. So just by cancelling the common datas on the both the sides, I'll arrive my E answer as 0.663. Next question. A border pit soil has dry density of 17 kilonewton per meter cube. And how many cubic meters of the soil will be required to construct an embankment of 100 meter cube volume with a dry density of 16 kilonewton per meter cube? So let's take and write the given. Here in this question they are talking about pit and embankment. So embankment is something where we need the structure or the ground surface has to be raised to certain level. To say for a hedge height I need to raise my ground level so as to lay my railway tracks or transport highways. So that is what embankment is. For that I need soil to be filled in this particular portion. So what I will do, I will just go borrow it from my another site and take that soil and use that soil to construct my embankment here. In this situation you will have certain properties. Say for volume, let's say volume, while digging the soil from borrow pit your volume will be something. After bringing into your construction site, that is your embankment site, it will change to some other volume. So I can say this volume is different from, that is borrow pit volume is different from embankment volume. So I will name it as my properties under pit. I will mention it as number 1, and properties under embankment I'll mention it as number 2. So volume 1 is different from volume 2. And also another property that will change is my dry density, gamma d. So gamma d1 and gamma d2. So this will change again. According to the given, in my borrow pit they have given a dry density value, and while talking about the embankment they have given that they need to construct the embankment for about a volume 100 meter cube, and which exact corresponding dry density will have 16 kilonewton per meter cube. And what is the volume that I need to dug it from my borrow pit? That is what they are asking for. While talking about the embankment and pit problem, this is the important relation that we will use it here. Then another one relation also is there to which relates volume and void ratio. We will see that problems also. So in this problem we will use this equation relation, important relation. After substituting the given V2 comma D1 comma D2, I will arrive at this equation. So from where I can easily find my V1 as 94.11 meter cube. Next, a soil sample has a void ratio of 0.5 and its porosity will be close to 2. In this problem, they have given void ratio and asked for porosity. The important relation that relates porosity and void ratio is this. So just take and substitute my void ratio values in this relationship. I will get my porosity as 0.333. So this porosity always represented in terms of percentage.